All right, today I'm going to talk about a couple sections from our probability unit. 10.2 is just basic probability. What is it? And 10.3 starts talking about experimental and theoretical probability. And theoretical probability is just regular old probability, okay? So we're going to kind of talk about those. I'll zoom this in for you. Key idea, probability of event is just measuring the likelihood that it will occur. For example, I have this number cube here, okay? If there's 6, numbers. And if I say, what's the probability that I'm going to roll this number cube and it's going to land on 0? That would be impossible because there is no 0 on here, okay? If I say, what's the probability that it's going to land on an even number? We know that we have 2, 4, 6. So that's 3 out of 6. So that would be here, right? That's equally likely to happen or not happen, and so on. If I was to spin my spinner and say, what's the probability that's going to land on a digit 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, that's certain because those are the numbers that are there, okay? So it's just a way to measure the likelihood of something to happen. Finding the probability in an event is exactly what we did here, right? What is the probability that I'm going to roll this number cube and it's going to land on a 5? So the probability that it lands on a 5 is the number of favorable outcomes, which is from our other unit. And if I wanted it to land on 5, there is 1 favorable outcome, right? And the number of possible outcomes is 6 because there's 6 different options. So the probability of this landing on a 5 is 1 out of 6, which if you were to come over here, 1 out of 6, 1 divided by 6, you guys, is about 17%. So that's not likely. Okay, so we would say that's unlikely. You can never say it's impossible unless it's at 0%. So anywhere between 0.1 and 25% would be unlikely. So let's go ahead and give it a try. Yep, see, look, unlikely. So that's just, excuse me, basic probability, right? Favorable outcomes over possible outcomes. And then you name the event here, right? What's the probability that I'm going to spin this and it's going to land on a multiple of 3? Well, 3, 6, 9. Oh, didn't happen. Okay, there was 1, 2, 3 out of all of these, all right? Same thing here, pretty standard one, a coin, right? You have heads and tails. You have a 1 in 2 chance. This is a 50-50 chance, right? You hear it, so it's equally likely to happen or not happen. So that's kind of regular old probability. You kind of know that already. So if we get down here and talk about experimental and theoretical probability, experimental probability is just when you repeat something over and over, okay, more than once. I could say I have a 50-50 chance of flipping this coin, right? Theoretically, I have a 50-50 chance. But what if I flip this coin 50 times and tally all the marks? Am I necessarily going to have 25 heads and 25 tails? Not necessarily, okay? Even though it's a 50-50 chance, you're conducting an experiment. So it's the experiment and the number of times the event occurs over the total number of trials. So experimental probability is just when something happens more than once. All right, so if I look down here at this example, they took this idea of rolling a number cube, and you could see they landed on number 1 10 times, on number 2 4 times, on number 3 8 times, on number 4 11 times, and so on, okay? So it wasn't all equal, but if you look at it, you can see there was 50 total trials, okay? So the bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? So the probability of rolling an odd number, okay? Well, where are all my odd numbers at? Okay, where do we have them? We have 1, 3, and 5. This was rolled 10 times. This was rolled 8 times. And this was rolled 11 times. So what is that? That is 29. So it got rolled 29 times out of 50. Okay, so the experimental probability is 29 out of 50. or 29 divided by 50, right? You get 0.58, or you guys should know that this is 58%. All of these are acceptable ways of representing the probability. Oftentimes, experimental probability will get written as a fraction or a percent because it's easy to compare stuff. All right. Now, if we were to say the, theoretical probability, if I was just to roll a number cube and have it land on an odd number, right? That's 1, 3, and 5. That's 1, 2, 3 out of 6, right? That's 50-50. That's a 50% chance. So you can see when comparing your experimental probability to theoretical probability, it's not that off, and it shouldn't be if it's a fair number cube or a fair coin or a fair spinner, okay? So keep in mind, because the very last part of this is kind of comparing experimental and theoretical probability. Okay, let's look at example 2 here, making a prediction. I know my printer's losing color. So if it says if it rains 2 out of the last 12 days in March, if this trend continues, how many rainy days would you expect in April? Well, what do we know? We know the number of times the event occurs over the total number of trials. Well, the probability that we're going to get rain, because that's our event. Let me put a piece of paper under here. Equals 2 out of 12, because that's what was happening in March. And if this trend continues in April, okay, we could also simplify this, right? What does this simplify to? 1/6, okay? So that means 1/6 of the days it would rain. Well, how many days are there in April? 30. So we would just find 1/6 of 30, which you guys know is 5. So we can predict 5 rainy days in April. Okay, does that mean it's gonna rain 5 days? No, it means based off the trend, we made a prediction, okay? So that's kind of another way to look at experiments. Now, going back to this idea of theoretical probability, okay, that just means, this is kind of basic probability, you guys. When all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. For example, equally likely to flip heads or tails, right? If I want to flip heads, I have 1 favorable outcome over 2 favorable outcomes, right? Equally likely, because this is a fair number cube, okay? So if I want to roll a 6, there is 1 favorable outcome over 6 possible outcomes. When would something like this not be correct? For example, let me sketch this out really quick. What if there was a spinner that someone gave to you that looked like this, right? And this was lose, win, lose, lose. I don't know. Clearly, all of these spaces are not equally likely, so you couldn't use a spinner like this, right? The idea, everything has to be kind of equally likely, okay? So here we go. Theoretical probability. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Well, how many vowels are there here? I see E, O, and E. Okay, so the probability that I'm going to get a vowel, where your event goes right here, is 3 out of, well, how many number cubes are there? 1, 2, 3, 4, 5, 6, 7. 7. Okay? So the probability of choosing a vowel is 3 over 7, or about 43% if you're going to change it to a percent. All right? So it's pretty simple. What's the probability that I'm going to flip this coin and get heads? 1 out of 2. What's the probability I'm going to spin the spinner and have it land on, an even number? 1, 2, 3, 4, 4 out of 10. And then you simplify, of course. Okay, so theoretical probability is just kind of probability. Now, using theoretical probability, let's look at this question here. Example 4, the theoretical probability of winning a bobblehead when spinning the prize wheel is 1 out of 6. The wheel has 3 bobblehead sections. How many sections are on the wheel? Well, the probability that you're going to get a bobblehead, number of bobblehead sections, total number of sections. We know that it's 1 out of 6. 1 out of 6, okay? That's the probability. And it says here there are 3, okay, bobblehead sections, and this is our unknown. So we can set up a proportion to figure this out, right? 1 times x is x, 6 times 3 is 18. So there are 18 sections on the wheel, okay? So using what you know to, again, make a prediction, kind of like we did with the rain. All right, I don't have an example here because I've kind of been talking about it, this idea of comparing experimental versus theoretical probability. So if you have a coin at home, or you can even find a virtual coin or a virtual spinner, I'll give you some links in Google Classroom to kind of play around with. Conduct a little experiment, right? I know the probability of landing on heads is 50-50. I have a 1 in 2 chance. But if I flip this coin 100 times, there's no guarantee that I'm going to land on the head 50 times and land on the tail 50 times. Now, your experimental probability should be similar to the theoretical probability because it's a fair and equal trial. So, give it a try, play with some of the links that I provide for you, and that's that.